I'm going to do a real quick review of factor variables. We went over it in the introductory class recently, but it's important for this particular, for making graphs for one reason. Factor variables, if you create a character variable and you graph based on that, they're going to be ordered based on in alphabetical order. So creating a factor variable gives you control on which of your groups are listed first, second, third, so on and so forth. So this is something that you want to utilize in order to help with that. So just to go over what a factor variable is, just as of this review. So they can either be strings or they can be numeric as well. However, if they're numeric or if they're a string variable or look like a string, a factor variable has levels. As you can see down here, this city is a character variable in this case. You're seeing that these values are stored as Austin, Philadelphia, Charleston, San Francisco, and then they're in that string format. You can see that by the quotes that are around them. Now, if you look at the factor variable here, you see something a little bit different. So in this case, California is set as a 4 in the back end. Pennsylvania is set as 2 in the back end. So these here are actually, when it's a factor variable, they're labels, and what is actually stored in the computer is a number. So that's the difference between a factor and a character variable, and that'll be really helpful when graphing. Regardless of how it's stored, when you see it in your graph, it's going to show the label, which is really important as well. So how do we create a factor variable? It's pretty simple. We have our factor function here. We have our data frame. This is just a small example just so you can see exactly what to do. We have state.df, and we want to change states to a factor variable in this case. And I'm assigning it and basically overriding it by using the same variable here. You don't have to overwrite it. You can create a new variable if you'd like and use that in your graph. So this is the variable that we are converting to factor. The levels, that is what already exists in your data. So in this case, this is what will actually output from the file, but they were originally stored as the state symbols. So Alabama, Alaska, Delaware, Texas. But however, say in my graph, I want to show the full state name. To give them the levels that are already in your data, so you list them in a vector here, and we list the labels that would correspond with our levels, the ones that we want to actually see. And order matters here. So if you have, say, a legend with these things listed out, Alabama will be listed first, Alaska will be listed second, Delaware third, so on and so forth, when we create a graph. But because we are adding labels here, as we can see, this is the output. The full state name will be shown instead of these symbols here. So that is why it's super useful to create those factor variables. It's either to reorder them or to show different labels from what is in your data. So also another type of factor variable, we have ordered factors. So this is more relevant for modeling. For this purposes, you can create one like this and it will show up in the correct order in your graph. But just since I'm going over factor variables, ordered factors are basically categorical variables that have some type of order in it. So in this case, I gave an example of low, medium, and high. So in all cases, low is going to be smaller than high, and it's going to be smaller than medium. This is more relevant for modeling, but in order to make sure the computer knows that these are actually ordered and that high is bigger than low, you can add an ordered equals true statement, and then that will change it into an ordered factor. So keep that in mind. And I am just seeing right here that I accidentally cut off the closed parentheses here when I created this visual. So just make sure you close the vector here. So I think I just cropped it off by accident. So that is how you would create an ordered factor. So are there any questions about factor variables? I know that this is somewhat confusing if you haven't seen it before. Hopefully you guys have come to a couple of my classes and I've gone over this a couple times. All right. So the other important thing that we're going to need as kind of a prerequisite to today's class is the aggregate function. So if you are familiar with dplyr, this does the same thing as a group by and a summarize function. So in general, unless there's a really good reason not to, when I'm first teaching this class, I like to teach the base R functions, just because they're good to know how to use. For instance, there are two people on my team that have known R for a very, very long time. And tidy R didn't exist when they learned R. So they don't know, they never ever use dplyr or string R. They use the base R functions because that's what they're used to. If you don't actually learn the base R, I think that you're not getting a well-rounded education at the same time. So I think it's good to learn the base R functions, and then you can find those dplyr or tidy R functions that do the same functions. But that is why I'm going to teach the aggregate instead. So aggregate is used for calculating group statistics. In some cases, you can do, you can say find the mean of your raw data and build a graph off of it. I recommend doing it this way, using this aggregate function or a group by and summarize. The reason for that is there's a couple reasons. So you have more control over the look of the numbers. Say you're labeling the top of a bar with the value that makes up the bar. It will sometimes, in a lot of cases, round it in a way that you might not want. So if you have stakeholders that are not, they don't do a lot of statistics, you're probably going to round them to the nearest whole number or close to that. So you have a lot more control over the formatting if you create like a grouped statistic. Also, say you wanted to put percentages on to label those bars. It will not, and if you do it this way, it will not show the percentage symbol on your labels. But if you do it this way, there's a way to do that with a lot more control. So it gives you a lot of control for labeling purposes, which I recommend. It also, you won't have to overwrite your, say you want to change the groups like I just showed with that factor function. If you don't create a new aggregate group data set, that means that you'll have to override your original data. For the most part, I do a lot of manipulations to the data that I actually graph with to change how it looks. And those are things that if you're creating a model with that same data that you might not want in your original data that you're going to use for modeling. So I got that question last time I taught it. Can you do this within the graph? Yes, sometimes you can, but sometimes you don't want to. Or it just makes your life easier down the line if you create a group data set. The last reason to do it this way, if you have a large group of data and you find the mean within the ggplot function, it's really slow. So it will try to find that mean of that large column, and it's going to overwhelm your computer because ggplot was not made for that. So that's the last reason I recommend doing it this way. So as I said, the aggregate function creates group statistics. So you can find any statistics, like the basic statistics with this. So any function that would output for, say, one group would output one number, this would work for. So the examples here, you can do mean, standard deviation, median, etc. Anything along those lines. You could do quantiles. You could do IQR, things like that. Do keep in mind, and you'll see down here that these same rules for those functions, they apply when you're using it in the aggregate function. You'll remember, if you've been to my classes before, that I've told you when you use the mean function, if you have any NA or missing values in your data set and you do not put NA.RM equals true, it will return NA or missing for that group if it has missing values. So NARM, it stands for missing or NA remove. So that's basically taking out those values that are missing, and then it's calculating our mean in this case. So this first value here is basically what you want to find the mean of, or the standard deviation of, or the median of. So if you're a regular tidyr user, keep in mind that you do have to list the data set in front of it. So you have to refer to the data frame, and then use our $sign, and then put the variable that you want to look at. This by function, we have to put it in a list. If you can't remember this, or you do this incorrectly, just take a look at the help files, and that should help you. It'll tell you that you need to put it in a list. So in this case, we want to find the mean prescribing rate by region and by year. So that what is listed in the list function is one or more grouped values that you want to calculate the mean for in this case. So that hopefully explains exactly what's going on here. I also put labels down at the bottom, so if you go through this PowerPoint later, it will help you figure out what all of these mean. But as I said, if you're used to dplyr, go ahead and use group by and summarize. It'll work just the same. All right. Are there any questions about this before I move on? All right. So I'm going to use something, some technology today that I haven't used regularly in class before, and I probably should use it a lot more than I do. So it's called R Markdown. R Markdown is a great way of passing off code to stakeholders. It even is really useful if you're not passing on code, but you want to pass on results. The reason why. So you'll see here that this is simply all that it does. If you put this value, so you have these 3 tick marks, and we have R here, and you close with those same 3 tick marks, it basically chunks this code into one chunk. It will run it all only within that chunk, and then it will print the results below it. So anything that you print will show up. In this case, we're not printing anything, so it's not going to produce anything below it. However, an example, and I'm going to run the whole thing so I can show you the example. So this looks a little different than what you're used to as well. So in this case, and I'm going to do this, and then I'll explain while it's running. So this gives you, without actually having to highlight your code that you want to run, it gives you control on how you run it. So you can run selected lines just like normal, like you would with R. So this would be the same that you're used to. You can run the current chunk that you're in. You can run the next chunk. or you can run all chunks above or all chunks below. So it gives you control over that. So now this gives you a great example of the power of this. So for each individual graph, I put the code here. When I'm teaching this class, I'm going to do it a step by step. So the first one's going to look pretty ugly. So we have this graph. So this graph was created by this code. So it shows below this code. Basically, I printed it here, and the graph that was created by this code is shown below it. So hopefully that helps give you guys an idea of, or a lot more control and understanding on what code created what. And I did that for all levels of the graphs that I've shown. The other really useful thing, if you go up here and you click knit document, I'm not going to click it now because it's going to take a minute and I already have the results. So say I click that knit document, you'll see if it does that, you'll see down here, and I think I have, no, I do not have the code from that, but it'll show a bunch of percentages down here, and it'll run each individual chunk. And it will output basically exactly what you're seeing here, only in an HTML document. So I might at points in this class come in and show the graphs in here because they're a lot easier to see and they're the same product. So just what we saw there, this first chunk created this graph. And we can see here each individual chunk and the graph that was created by that chunk. So this is great for passing off code to stakeholders because you can have a lot of control over what your text looks like. Another example of that is down at the very bottom. I am giving you an exercise at the end of class, and I can put the steps in bullet points. There's a lot of things that you can do with it. So in our, if you go into the files for today's class, the OneDrive, I do have this offline, but you'll have to go to the link to see this. So in the class 5 ggplot2, there's an R Markdown cheat sheet that I believe that was created by either RStudio or someone, a user. I believe this one was RStudio. So it gives you a little cheat sheet of how to format your text, how to open, write, embed code, and there's a lot of options. So in some cases, you can hide those graphs if you don't want to show them. You can also hide the code and keep the output. So if you're passing on something to a stakeholder and they're not a programmer, that would be used in that case. So hopefully this will be pretty useful to you guys. A lot of people will use it at work just to show code so people can review that code easier. But since this is new, and it's going to affect the way you run the code, I did want to go over that a little bit to you and tell you what it creates and how you can leverage that.